Star Gwen, Deputy Aeronautics Research Director at NASA, to the stage.
Well, good morning, everyone. Welcome to day 2 of the 2024 AIAA Aviation Forum. Hope everybody's having a good time so far. My name is Star Gwen. I'm a proud member of the Aviation Forum Guiding Coalition team that helps put together this conference. I work at NASA Armstrong Flight Research Center. And I'm pleased to have the honor to begin today with 3 awards and then introduce our plenary speaker. So our first award is the 2024 AIAA Low-C Atmospheric Science Award. It's presented in recognition of outstanding contributions to the atmospheric sciences as applied to the advancement of aeronautics and astronomics. The 2024 AIAA Low-C Atmospheric Award is presented to Dwayne Walliser. Dwayne is the, thank you. Dwayne is the Chief Scientist of Earth Science and Technology Directorate, NASA Jet Propulsion Laboratory. The award citation reads, "For highly impactful science and leadership contributions to the atmospheric and Earth system science that have progressively advanced and leveraged space-based Earth observations." Congratulations, Dwayne. Our next award is the 2024 AIAA Plasma Dynamics and Lasers Award. Recognizes an individual who has made outstanding contributions to the understanding of physical properties and dynamic behavior of matter in the plasma state and lasers as related to aeronautics and astronautics. The 2024 AIAA Plasma Dynamics and Laser Award is presented to Kurt Polzin, Chief Engineer, Space Nuclear Propulsion, NASA Marshall Space Flight Center. The award citation reads, "For seminal modeling of pulsed inductive plasma accelerators, providing both the fundamental understanding of underlying physics and practical approaches to optimize the energy deposition." Congratulations, Kurt. Our final award this morning is the 2024 AIAA Thermophysics Award, presented for outstanding singular and sustained technical or scientific contribution by an individual in thermophysics. The 2024 AIAA Thermophysics Award is presented to Greg Natter, Vice President, Academic and Research, University of Prince Edward Island. The award citation reads, "For significant contributions to heat transfer and multi-phase flows, thermochemical processes, and thermal design using entropy and the second law of thermodynamics." Congratulations, Greg, and to all the award winners. Okay, now, it's my pleasure to welcome our plenary speaker this morning, Amanda Simpson. Amanda is an advisor and consultant on aerospace, energy, and DEI as the CEO of Third Segment LLC. Formerly, she was vice president for research and technology and head of sustainability at Airbus Americas. She has worked across the aviation industry in the private sector and in government. Amanda served the Obama administration as Deputy Assistant Secretary of Defense for Operational Energy. Previously, she was the director of the U.S. Army Office of Energy Initiatives, special assistant to the Army Acquisition Executive, and senior technical advisor to the U.S. Department of Commerce. Amanda has received numerous awards and recognitions. She is the AIAA Fellow and is also a Fellow of the Royal Aeronautical Society. She was appointed by the U.S. Transportation Secretary Pete Buttigieg and serves on the FAA Commercial Space Transportation Advisory Committee, or COMSTAC. Amanda holds both an airline transport pilot certificate and a certified flight instructor license. She has logged over 3,000 hours of flying in more than 60 different types of aircraft. Today, Amanda is talking about shifting the transportation paradigm. At the end of Amanda's talk, I'll rejoin her and we'll take questions from the audience, so please use the QR code. And please join me in welcoming Amanda Simpson.
Well, good morning, everyone. I think I see some familiar faces from aviation's past. You know, I've been on this stage before. Well, actually, I'm going to remember a specific time when aviation was in Dallas, and I got to introduce a gentleman by the name of Brian Tillwigger, and he was a film director and producer, and was premiering a movie called Living in the Age of Airplanes. Now, if you haven't seen that film, I really encourage you to get a copy. It's on the National Geographic Channel. But what it does is it talks about how the world has changed since aviation became part of our society. And so, kind of riffing off that, I wanted to talk about what technology it's taken and how we've gotten to where we are today, what we're working on, and really where the future might be, and how we're going to shift that paradigm for the future. So if folks were here yesterday, and when Russell and Dan were talking through a variety of the technologies and some of the milestones that were coming up, this kind of morphs off that, but at the same time, we're going to look a little bit deeper. But I also encourage you to come up with questions. But to start with, we're going to do a history lesson. We're going to look at some of the milestones that have shaped where we are today in aerospace. And I'm just going to let these roll, and then this will give you an opportunity for the next 5 or 6 minutes to completely ignore me and look at the slides on the screen. But believe it or not, the aviation history begins about 3,000 years ago, and this is not an actual photo, but a recreation, where in China they used kites to actually lift people up so they could observe the enemy. And then we move forward a couple of hundred years, the first balloon flight, and then of course the first ever crossing of the English Channel took 2.5 hours in a hydrogen-powered balloon. First photograph of the moon, an important point when we think about remote observation. First time a man was carried on a glider. We're still not to the point of powered flight, but soon after that, people were looking at the technology that was necessary to control flight, years and years before they were actually put into use. And of course, the pivotal publication on how to look at what was going on in birds that could be applied to flight. And of course, everyone remembers the first powered flight, but how many remember the first helicopter flight only a few years later? Not a pretty picture, but it got the job done. And then we had finally an airplane that was able to cross the English Channel. These are some of those big milestones. I love this one. The guy's carrying a huge radio set. So there we go, a wireless message from an airplane just sitting there in the passenger seat. First transcontinental flight only took him 84 days and made 70 stops along the way, some of them not intentional, by the way. And then we get to the point where we actually now have commercial airlines. And if you go to St. Petersburg, you can see where that airplane launched as it would fly all the way to Tampa and back, right? And now we have a first transatlantic flight. And we're now getting to the point, and then here's a favorite, first aerial refueling over Long Beach, guy carrying a 5-gallon jar of petrol on his back as he transferred between airplanes. And then the Army does their first round-the-world flight, 175 days with 74 stops. Of course, then we start getting into rocketry with Wernher von Braun, and now we have trans-Pacific flights. Now, this was island hopping, so it certainly took its time. And then airships were now looked at as passenger service, and they actually showed that they could do a round-the-world flight. And then Jimmy Doolittle showed that he could fly solely, take off and land solely by the use of instruments, which led to the development of flight simulators. A lot of work and think about how flight simulators influence what we do. And then finally, years later, we now have a nonstop trans-Pacific flight. And then finally, a practical helicopter, right? Something that starts to look like what we have today. And then the jets come during World War II. And then the first rocket to reach space. Test flight of a V2 that went straight up. And then supersonic flight. Many of these things I know that you recognize, but it doesn't take long for, not only do we have the first artificial satellite with Sputnik, but now we have aircraft that will leave Earth orbit. Luna 1 becomes orbiting Sun, so it's an artificial planet, and Luna 2 actually becomes a satellite around the moon. And then we have our first, Yuri Gagarin. And by the way, this is where I'm born. So now this is where my history, I remember things that happened after that, right? You start now exploring the planets, right? And then your TV, and we start getting relay and live television from around the world. And of course, now we're starting to explore more and more what's going on outside of our planet. And by the way, you know, here we are, we figured out how to put something soft on the moon, and it wasn't but a few years later where we put humans on the moon. And then we said, okay, let's look back more at what's going on Earth, and we got Soyuz 1, a manned laboratory in space, and began our exploration in living in satellite. But now we start looking at what's going on our planet, right? But for supersonic service with the Tupolev 155, interestingly enough, it does not make it to its destination on its first flight. It has to make another stop. And every time we're doing all these things, we're looking at new technology. We say, if we want to do something, we want to make some advance. We have to develop these new technologies to make it possible. And so as we're working on things today, what are those technologies that will get us to those first steps, right? And here we have Pioneer 10 leaves our solar system in '83. And actually, this is a friend of mine, George Pinky Nelson, repairing the Solar Max on orbit, actually doing work in space as a human satellite of his own. Hydrogen-powered flight, yeah, it goes back quite a ways. Where are we at now? Oh, the 777, first aircraft to completely be designed on a computer. And then we start putting rovers on Mars. And then the first module of the space station, Zara, it goes up in 98. But we're still looking at balloons. Not necessarily a practical application, but how do you go around the world in a balloon? And here we are in 2000, and we begin what is now a permanent presence in space. And of course, a year later, you get the first space tourism begins. It's been going on for a while. That was Dennis Tito. We get hypersonic scramjet tests. And then, of course, the X Prize, which pushes the ability to have a reusable commercial asset to go into space twice within a 2-week period. And pushing satellites around, comets, and taking measurements. We have spacecraft that now can go all the way out to the furthest reaches of our solar system and bringing material back from an asteroid. And now, how about electric flight? A multi-copter. Not exactly sure I'd want to sit on that thing, but or get diced to pieces. And we've been using biofuel now for about a little over a dozen years. That was a KLM flight from Amsterdam to Paris. And then we have electric aircraft that can cross the English Channel. And now we're looking back at space, right? We have now the ability to return a booster and land it safely for reuse. All these are these incremental steps of technology that will lead to new applications, to new utilizations. And we're actually now, and finally has retired, flying an aircraft on another planet. And now we have commercial, well, not yet regularly scheduled, but we have tourism in space. So there's all these things that are going on. But what are we looking at today? If we're going to shift the paradigm, we not only have to be able to look back at the technology that's moved us forward, but look at what is going on today. This is my only chart with a lot of words on it, and because there's just so much going on with regards to cleaner travel. Right, we think about all the new fuels, and whether it's the sustainable aviation fuel, which is a solution to get us on the path towards cleaner aviation, but also unleaded aviation gasoline. Yes, piston aircraft are still using leaded gas after all of these years, and we're finally starting to test unleaded aviation gasoline. The promise of liquid hydrogen, the ability to burn a fuel that only emits water vapor, and of course the challenge of batteries, which are heavy, but allow for a zero emission vehicle. Fuel cells, which can take hydrogen and convert it to electricity to power larger and larger electric motors, and of course that hybrid concept where you're burning a liquid fuel of some sort, whether it be jet fuel, gasoline, or even sustainable aviation fuel, or possibly hydrogen. It's being developed for automobiles, possibly have an opportunity for an application in aviation. So different ways of thinking about how we fuel the aircraft to be cleaner. New propulsion technologies, larger and larger, more and more efficient electric motors, the ability to take hydrogen and combust it directly rather than even going through the process of converting it to electricity. Open rotor technology, advanced geared turbofans. I know I'm missing some things, but there's 1,100 plus papers, technical papers being delivered this week, and they're talking about many of these subjects. And of course in aerodynamics, whether it be blended wing bodies, vortex generators to help small parts of efficiency. I know I have some vortex generators I've added on my aircraft. High aspect ratio wings, as wings get longer and thinner, how to get more and more efficiency out of these aircraft, and newer materials that will mean lighter weight. So an amazing amount of attention on clean aviation. Another one I think that is getting a tremendous amount of attention and has many players is advanced air mobility. Now I have a kind of a unique claim to fame, is that many years ago, a little over 20 years ago, I was one of the first FAA licensed pilots to fly an N-numbered registered UAS in the National Airspace System, which was kind of an interesting thing to go through, getting those kind of approvals. But there's all these different models out there that are all trying to tackle the ability to move individuals from one place to another quietly and efficiently, and potentially revolutionize the way we think about transportation. And a huge part of what needs to be thought about here is how do you manage the traffic? Today's air traffic management system is already close to its capacity. And now when you talk about 2 or 4 or even more times as many aircraft, how do you keep them separated? How do you control or have their ability? You know, there's work on putting together the landing facility, but you can't just say they're going to land on the top of a building, because now they have to potentially, if they're electric, they have to stop and recharge. And where's the next aircraft going to land? So there's a lot of work going on beyond the vehicles themselves that are really going to determine the future viability of advanced air mobility. But part of that is, so how do we take aircraft of today and look at making them quieter? You know, I was just reading an article where Boulder, Colorado is suing the FAA because they want to be able to close the airport because it's too noisy. Amsterdam, one of the major airports in the world, connection hub, is trying to limit the number of flights because it's too noisy. But aircraft are getting quieter, and there's so much work on quiet transportation, whether it is in vertical aircraft or in longer range aircraft. I think last year we had the debut of the Whisper Jet, which actually takes the sound frequency of the electric motors and shifts it out of the spectrum of the human hearing, which I thought was fascinating. You have compound helicopters, blended wing bodies, lots of different ways to make aircraft quieter and thus more compatible with the technology and the societies around them. And then the amazing breakthroughs that are going on with long distance travel, whether it's the recently certified A321 XLR, which is for the long, thin routes, or the 777-8 or the A350-1000, which will be able to connect any two commercial airports on the planet nonstop. Think about that. We now have large passenger aircraft that can fly between any 2 points on the planet, carrying hundreds and hundreds of people, tons and tons of cargo, nonstop. Long flights, no doubt, but we now have that ability. And where are we going to go next with regards to that? We want to go faster. A couple of projects that are in the work. You're going to hear a lot about the X-59, the Quest aircraft that will be looking at how do you make the supersonic travel quieter. Instead of a supersonic boom, you have a thud. And will that make a difference and be able to relax the prohibition for supersonic flight over land here in the US and around the world? And then, of course, there's Boom. I'm not always so sure that's a great name for a company, but they've just started flying their XB-1 prototype on their way to developing the Overture aircraft, which will be a 1.6 Mach commercial aircraft that'll start having transatlantic service probably by the end of this decade is their goal. So work on how to get there faster. I think there was an interesting conversation yesterday about how big is the world to a business traveler, and the answer was 4 days. A day to get there, a day or so to have your meetings, and a day or so to get home. Faster is going to continue to shrink the planet from, remember when it was, took 40 to 70 days to go across the country. Now we do it in hours. How do we get these things down to single hours or less? Well, one way to look at it is how do we take advantage of what's going on in space travel, right? We've got the SLS, the Space Launch System that NASA is developing for long-range interplanetary and translunar work. You have the SpaceX Starship, which is getting close to what they would think would be operational status, which amongst other things they are talking about using short-range suborbital flights to go from point A to point B on the planet in a mere number of minutes rather than in days. And of course, the Blue Origin New Glenn is getting ready for its first orbital test flight. So work going on with the regards of the space launch systems. And then there's the space station. We've had the International Space Station up, as I talked about, Probably it's 26 years since the first part got up there, but what's coming next? Certainly, China has the Tiangong space station now in orbit. That's a photograph that was recently taken of it. And there are competitors to replace the International Space Station, whether it's the Axiom Station, the Orbital Reef, or Starlab, or maybe multiples. Commercial applications of long-term habitation in orbit. It's going to be very interesting to see where all this goes. And there are people at this conference, or the one down the hall, that are talking about all these different types of activities, the technologies that have to be developed to support these activities. And then there's the moon. We talk a lot about how to go back to the moon. And so whether it be the Lunar Gateway Station, potential lunar landers, lunar rovers, having a long-term lunar outpost, all these are new technologies that have to be developed. And I think one of the critical ones is, how do you generate fuel on the moon? We know that the components are there, all the ingredients to make the fuel to replenish these vehicles that land there and potentially use the moon for a launching pad to go into deeper in space. That technology is one that is working in the laboratory, but how do you get that developed to the point where you can actually now create fuel, create water, create oxygen from the materials on the moon? And that's going to make a big difference as we look for permanent habitation on our nearest neighbor. One of the things I talked about, which is becoming more and more important, is how do we look at our own planet? How do we assess what's going on here on our home? And we have lots and lots of activities for new sensors that are looking back at us. Think about weather observation, climate monitoring. I think I've got a couple up there. There's the JPSS-3, the ISRO, Forum, Truce, Maia, the Sentinel-6B, Libera. Between the countries of the planet, we're looking harder and harder at what our impacts are on our planet so that we can understand what we're doing and what we need to do if we're going to continue to make Earth Spaceship One. Lots of different things going on there. But then we are also looking at what's going on further out in the solar system, whether they be probes being developed by NASA, ESA, or even the Chinese, the Europa Clipper, the Da Vinci Dragonfly, Roman, Bepi, Colombo, Hera, Juice. I have Viper up there, but it just got canceled. So a lot of activity going on there. Looking at how do we harvest as we go further out in the solar system, what is on asteroids, right? How do we harvest those materials? How do we deflect an asteroid that potentially could impact Earth? Planetary defense. These are things that are that are actually today being evaluated, that are being considered, that people here at this conference are working on developing the technology. But there's things a little bit more personal, right? What can we do for personal air travel, right? It's one thing to get on an aircraft or even potentially fly in urban air mobility, but what do I put in my garage? What do I keep in my hall closet that's going to allow me to get quickly from A to B? And there's all sorts of ones flying today or are being developed, whether they use jet power or propellers. These are real things. You think about it. Flying cars are here. Not very many of them, a lot of prototypes, but how do they get to the point where they become something that is marketable? How do you integrate this into our air traffic system? How do you train people to fly a jetpack? So I thought this is fascinating to me. This is truly Jetson stuff, as we were talking about yesterday morning, if you were in that session. And then, of course, artificial intelligence. Whether it's machine learning or large computer networks, the impact of artificial intelligence is going to make a tremendous impact on the future of what we're doing in aerospace, right? There's already a satellite, the FESAT-2, that is going to use artificial intelligence to make its determinations on its own in space, right? But the impacts on how an aircraft itself operates, the impacts of air traffic control, the impacts of manufacturing, there's so many different avenues that are still being explored, that are just beginning to be explored, that are going to have a huge impact on the aerospace system. But the question becomes, okay, wait a minute, so I have a list here I got to talk about. Simulation-based certification. More and more times we're actually using computers and AI to predict the operation of aircraft and space systems so that we don't actually have to fly prototypes as much. Data-based, data-driven physical modeling, reduced models for multidisciplinary optimization, the ability to understand how one discipline will affect a different one, and using computers and AI to help there. Defining AI as an expert system for design. And of course, robotic systems, particularly for on-orbit repair, where you don't need or don't want to put a human at risk. Monitoring and assistance in piloting and flight operations, remote space exploration and exploitation, where the time delay for remote control is just too large, and we're going to have to rely on artificial intelligence. There's really some huge impacts coming in the AI field. But what does the future hold? What are those novel technologies that are going to be required to get us to the future? What is your vision of the future that you want to be working on, that inspires you to think about what you want to see, what you want others to be able to take advantage of? What brings you to this conference, some of us year after year, to help push these ideas forward? Maybe it's that hypersonic aircraft that's going to be able to fly 3 to 5 times the speed of sound and move people around the planet in literally single unit hours instead of 18 to 20 hours. Maybe it's that advanced air mobility system that integrates all these different modes of transportation seamlessly into an operation that moves people and declutters transportation on the ground, opens up that third dimension for personal travel. Or maybe you do want that flying car in your garage, whatever that might look like, and get something into production that allows anyone to just literally take off to their destination and get there quickly. But maybe that's too much for you. And of course, I think my son loves this one. He's a millennial. That personal jetpack that you're just going to strap on and head off to your next destination. Or maybe that's not enough. Maybe you want to be able to, soar out into outer space and have, that Buck Rogers moment. I think this is amazing. For some reason, he still found a way to be on his phone as he's flying there. But where do you go? right? You know, some of us have been thinking about what that hotel in space, what that permanent space station might look like since we saw this drawing 40 years ago, right? And what is that going to be? What is that permanent outpost in our orbit going to look like? And, you know, we talk about the ISS replacement, but what does that lead to, right? Or maybe it means that eventually we have a permanent presence on the moon, right? What are the things that inspire you to be here? And maybe it's to build that next device that's going to go out and explore another planet or moons of another planet, or go beyond the solar system to see what's out there. And maybe rather than sending a robot, you want to be part of that future where we develop interstellar travel. There's lots of opportunities to maybe think about as we start to colonize and put a presence out on other planets. What is it that's going to inspire you? And you know, I'm gonna leave that to you to decide. You need to go and create the future that's going to mean something to you, mean something to those who will fill this room in 20 and 30 years from now. Develop the technology that's going to inspire and drive us all forward. That's why we come here. It's that vision that will drive us. And I thank you for your time. I hope that you found this look ahead, based on a look backwards, something of interest and something that'll make you walk out of here and have a smile on your face thinking about the opportunities that we have in the future. So, thank you.
Great. We'll take some questions now. That if you haven't put a question in, we have quite a few of them. So for this short amount of time, we'll see how many we can get through. But if there's any other questions, please put them in. So first, you started with your talk with making the aviation sector cleaner. How does supersonic fit into that?
Well, you know, I think it's interesting because we have all these competing desires of people. You know, there is a desire to go faster, but how do you do that and balance that with cleaner, right? How do you think about the impact on what we're doing on society versus the benefits to society? You know, some of us in this room are concerned and try to figure out how to make that balance. And there are some people who are just looking at the technology straight out. You know, I'm not, in my career, I started out as a technologist many years ago, but became a policy person. And so those are kind of some of those things that we look at. Some, you know, running a supersonic aircraft on sustainable aviation fuel does not make it cleaner, does not make it quieter. But maybe there will be a fuel that will do. Maybe there's a new engine technology out there that will burn hydrogen, you know, and overcome the challenges of volume to make these things happen. Maybe it will be, you know, suborbital space travel from A to B. I don't know what those are, but we need the technology to help us make those decisions.
Yeah. Next question, do you believe the infrastructure needed for these new technologies is being developed at the pace required?
Well, absolutely not.
That's what I was thinking.
I mean, there's a lot of chicken and egg questions here, right? When you think about, for instance, hydrogen-powered aircraft, and whether it be in the advanced air mobility or the short-range transport, there's a lot of talk about, you know, making hydrogen the fuel of the future. But where's that fuel going to come from? The amount of hydrogen being produced is about 1,000th of what's required, not just for aviation, but for ground transportation, So how do we catch up with that and the distribution and transportation to meet those demands? We talk, there's talk about all these advanced air mobility, but where's the vertiports to support that? Where's the air traffic management system that's going to support that in the future with tens of thousands of vehicles? It's one thing to say, well, I'm going to restrict this airspace so that this package can be delivered to someone's backyard. But that's not a very efficient way when you start talking about the numbers that are coming. So there's a tremendous amount of infrastructure work that needs to happen to support many of these opportunities.
Next question, in the transportation system of the future, what are the technology gaps in aircraft design or system that are needed?
Oh, there's many. I mean, just because someone has a vision of a Mach 5 transport doesn't mean we have the knowledge on how to build it today. We don't have the technology for the materials. The engines are still very immature. There's ones that we've shown that can operate for seconds, whereas they need to operate for, fractions of hours. There's development work going on, but there's so many questions that haven't been answered. In that opening, when I talked about all those different technology, all those different milestones, every one of those milestones required some leap in technology to make it happen. The ability to go farther, the ability to go higher, the ability to go faster. If you look at the AA logo, it is all about faster and higher. But today, some of those questions have been answered, but what's going to be next? And I leave it to you to determine what those technologies are to make those things happen.
Next question, with us creating supersonic jets like X-59, how long do you think it will take to see supersonic aerial transportation in the commercial industry?
Well, we did. Some of us remember when supersonic transport was something that happened every day. But there was, the economic factors, which everything I talked about is going to boil down to economics, right? Who's going to pay for it, and is it worth it? The economic drivers for supersonic transport weren't there. The Concorde was unsustainable at the prices at which it was operating, primarily because the aircraft became 20 plus years old, and getting parts to keep those massive Olympus engines operating were just too high. And all it took was one accident to lead to the grounding and the discontinuation of that. Will it happen again? I think it's possible. I don't know. Boom says that they can get the price down to a first-class transatlantic airline ticket. That's, I think, very ambitious, and we'll see if they get there. They're building a factory. They've designed the aircraft several times over, I might add, as they look at new technologies that they can incorporate to make that aircraft more efficient and to operate. Will it happen by the end of this decade as they promise? I don't know. I'd like to see it. With all the aircraft that I've flown, I have yet to fly supersonic. So that's maybe one of my goals.
There you go. Next question. What criteria do you suggest we use to select what technology to focus on while balancing better, faster with sustainability?
Yeah, that becomes the question. And again, it's, we can make choices on what we want to work on, but someone's got to pay for it. So whether it is that entrepreneur working in their garage who is developing something at super low cost, which we see, whether it's the billionaire who decides to pursue one avenue and will fund development with unlimited financing because that's what they think is important, whether it's a government that believes that that is a priority and is going to fund that through their labs and pass down that fund to private industry and to academia, those are the ones that are going to be making those decisions.
Let's see. Let's move this up. Do you think the innovation beyond sustainability will be human and user-focused or hardware and technology-focused?
For those of us who have watched the aviation industry mature and change, for myself over the last 60 years, since jet travel was introduced, it was very much originally for those who could afford it. And it was very luxurious, and it was very focused on the human experience of sitting in an aircraft and flying across the country or across the ocean. But as the airline industry matured, there were some who said, we're going to make it that exclusive experience. And others that said, we're going to really focus on low cost and focus on getting drive economics into the aircraft, and we're going to put as many people on. And forget about the human experience. Certainly when I was at Airbus, we would get all sorts of proposals that I thought were unique, to say the least, that were focusing on the hardware and completely eliminating the human from the calculation. Not about comfort, but how to move things, i.e. people, efficiently and cheaply. And people get to vote with their pocketbooks. I'm going to go back to what I talked about at the beginning. Living in the age of airplanes, what it has brought to our society, the ability to move people and products and ideas and connect that across the globe. We live in a time where families live across the planet, and we don't think much of it because we can get on a plane and join them. But there was a time where families didn't go beyond, an hour walk away. So what's important for the future? And now those are decisions that people in this room and people who, that will be making those decisions are really focusing on for the future. And it's not an easy one. And we don't know which way it's going to go. But here we have the opportunity to kind of guide that.
We do. Well, thank you, Amanda. Really appreciate it. Thank you for sharing all your insights with us today. And we have the AIAA Challenge coin. Let's give a warm applause to Amanda. Thank you. Okay, now we have a special announcement from Gwen, the CEO and founder of GoAERO, who has an exciting challenge she's working where we're going to all try to save people's lives. So, Gwen, you're up. The video, please. Or not. Here we go. Yes.
We see heroes every day. Heroes who look past danger to help people in need. Heroes who step in to be the difference between triumph and tragedy. And heroes who use their minds to create technology that saves lives. We need those heroes. We're launching a new prize competition for a singular mission, saving lives. More than $2 million in total prizes is on the line for the best thinkers, creators, and inventors to stretch and challenge their minds, to change the way we reach people in the face of disaster, unlocking a new era of rescue response. An era that unleashes the power of autonomy, speed, and precision. Alongside NASA, Boeing, and RTX, GoAERO is looking for the brightest, boldest, and bravest innovators to change the way we rescue and respond to disaster. This is your chance to make history and save lives. Join us. Ready, set, GoAERO.
Good morning, everyone. I am Gwen, and I want to just take a moment to thank Dan and Jim and everyone at AIAA for putting together this conference. As we all know, it takes a Herculean effort, so thank you all to the AIAA team. Thank you. So we are GoAERO. We are a global competition, and we are focused on a singular mission of saving lives. There we go. GoAERO is supported by Boeing and NASA and RTX, and last week we announced our newest partner, Honeywell, along with AIAA and the Royal Aeronautical Society and Vertical Flight Society and 3AF in France and 30 different organizational partners around the world. And together we have come to bring this competition to the world to create emergency response flyers. These are aircraft that bring a first responder to someone in need, or rescue someone who needs help, or brings in emergency supplies or products. As we all know, there have been increased natural disasters, there are humanitarian crises, and there are everyday medical emergencies. At GoAERO, we are asking teams around the world to join us in this design, build, fly competition to create emergency response aircraft that help in these situations. And specifically, we are conducting a 3-year competition with over $2 million in prizes awarded along 3 different stages. There's the paper stage, which runs this entire year. Next year is the prototype stage, where prototypes can be full-scale or subscale. And then after, we culminate in a final fly-off in February of 2027, where teams around the world gather to join us. What we're asking teams to create is a safe and portable, robust, autonomy-enabled flyer that responds to challenges posed by natural disasters, climate change, medical emergencies, and humanitarian crises. Now, you may ask, what is an emergency response flyer? And if you think of a helicopter at one end of the spectrum, and helicopters are great emergency tools, but they require a pilot, they are expensive to procure, more expensive to operate over the course of their lives, and they have trouble in and out of tight spaces. At the other end of the spectrum, from the drone world, you have Zipline and Amazon transporting 5-pound payloads, and they're great for what they do. But what we're asking our teams to do is fill the gap in the middle. It is inventing an aircraft that can bring that first responder to someone in need, rescue someone who needs help, but is larger than the drone and smaller than the helicopter, and more maneuverable. And also, as you see from this photo, trailerable. And so our hope is that after the competition, teams around the world then partner with municipalities, and in every firehouse and in every police station, they can trailer this emergency response flyer, get where they need to go, and when they can't go anymore, launch this aircraft, such that it is an extra tool in the toolbox. These specifications and the technical rules that we wrote were informed by countless interviews and discussions with first responders all around the world over about a period of a year. And so when we asked teams to do the 3 missions at the fly-off, adversity, maneuverability, and productivity, they have all been informed from these countless conversations about what that gap is in emergency response that current aircraft do not do. So, why are we here today? Why do we have all the amazing partners? Well, we've just launched the competition. It's 3 years. We are in the very beginning. We are inviting teams around the world to join us in the competition. A team can be an individual of one. A team can be a university. A team can be engineers at any stage of their careers or entrepreneurs. It can be a small business, a medium-sized business, a large business. But what we are doing is coming together to create this technology. If you're interested in forming a team and learning more, the QR code can take you to our website. My colleague, Guy Sartorius, will be speaking tomorrow on the technical rules at 10 a.m. in the hub. And an important thing to note to all of the teams is that teams keep their own intellectual property. All right? We want teams to be able to commercialize what they do after the competition. And at GoAERO, with all of our partners, we provide online webinars to help our teams in engineering and fundraising. We provide one-on-one mentors to our teams. And we have a whole host of in-kind sponsors to provide free and discounted software and services to our teams. So we are really, along with AIAA and everyone who has joined us, a convener and an accelerator so that these emergency response aircraft can save lives. I'll share a personal story with you, which is something that I don't normally do. But several years ago, I was with my parents at their home, and my father started having chest pains. And we called 911. And the ambulance came very, very quickly. And I got in the back of my car to follow the ambulance. And as we were driving towards the hospital, there was just a ton of traffic. And I remember saying over and over again, please move, please move, please move. My father got to the hospital on time. We celebrated his birthday a couple of months ago. Everything worked out well. But my experience was not unique. There are thousands of people around the globe every day who say, please move, please move. These emergency response aircraft are designed so that we never have to have another person have that anxiety, and our loved ones can all get the medical help they need, whether it is an everyday medical emergency, a natural disaster, a humanitarian crisis, whatever it is. We ask you all to join us. If you're interested in forming a team, this is the link. If you're interested in being a mentor to help teams, please let us know. You can go as well to the website and be a mentor. And if you'd like to join NASA and Boeing and RTX and Honeywell and AIAA and all of our organizational partners, and we are looking for additional prize sponsors. We are looking for additional collaborators and additional people to come into this ecosystem and bring emergency response to life. I thank you for your time. We are happy to answer any questions that you may have, and we look forward to taking on the challenge of the next 3 years and building this aviation technology that saves lives. Thank you so very much.